At the heart of every great city in the world, London, Paris, Moscow, Tokyo, lies a troubling paradox. Attracting more and more people is the key to sustaining their rich culture and thriving economy. But it's this very crush of people that makes it harder and harder to get around. To solve this riddle, engineers have looked away from crowded streets and grand boulevards and gone underground instead. Every day, somewhere in the world, 40 million people ride the subway. In London, it's the tube. Paris, the metro. Tokyo has a subway. And so does Hong Kong. And then there's New York City. 3,484 skyscrapers crammed into 20 square miles of some of the most expensive real estate on the planet. While underground lies the subway that keeps New York moving at such a frenetic pace. 842 miles long, transporting 4.5 million passengers a day. Early on, the New York subway was the greatest and most advanced mass transit system in the world. But after years of neglect, New York's prized system would literally start falling apart. Today, the subway is coming back with plans for a new super system that will take it deeper, further, and faster than ever before. Can it be built? Will it work? Would it bankrupt the city? Will New York's ambitious plans lead all other great cities into the future of mass transit? Or become the engineering boondoggle of all time? City. 8 million people crammed into so little space, they practically trip over each other. It can feel like there's no room to move. 12,000 taxi cabs choke the streets. And if it starts to rain or snow, as they say on the streets of New York, forget about it. And yet, somehow New Yorkers manage to get to work and to get home on time. How on earth do they do it?
Grand Central, 42nd Street.
They take the subway. You can get from almost anywhere to just about everywhere in New York by subway. 26 separate lines weave through 240 square miles. Have to get from the northern tip of Manhattan to the edge of Queens 31 miles away? No problem. You can take a ride on the A train, B train, the C train, D, E, F, right on through W. Or you can do New York by the numbers. The 1, the 2, 3, 4, and on through 9. In all, 7,000 subway cars stop at a remarkable 468 stations. Nearly as many as all the other subway stations in America combined. A trip through the entire New York subway system would take 21 hours. That's the same amount of time as riding the train from New York to Chicago.
We run over 7,000 trains on an average weekday, and we carry over 5 million people. We truly are the lifeblood of the city of New York. We are what keeps it running.
New York itself has 8 million citizens, and we provide 7 million rides a day on public transportation. New York wouldn't work if everybody were in cars. It would simply shut down.
There's no way that this city could be what it is. It couldn't be the center of commerce. It couldn't be the center of finance without the New York City subway system.
But the current subway system may not be up to the challenges that lie ahead. By 2020, experts forecast an additional 280,000 people may want to ride the subway. 105 million additional round trips every year. Subways have become the hallmark of great cities, the circulatory system that keeps them running. London's Tube carries 2.5 million riders a day. In Paris, 4.5 million ride the metro, while Tokyo crams in 7 million riders a day. Cities like Madrid, Hong Kong, San Juan, and Sao Paulo are expanding their subways or creating new ones. While New York has struggled just to maintain a system that's now 100 years old. Nothing can work that hard for that long without falling into disrepair. But after years of neglect, New York subways have recently made a comeback. Plans now exist for the largest, most advanced mass transit construction project in history, costing $30 billion and counting. It's an ambitious plan, a super system that will push the limits of extreme engineering into new frontiers and make New York's system once again the greatest in the world. The New York subway had earned that title soon after it was completed in 1904. Before the subway was built, the only means of public transit were horse-drawn trolleys and filthy elevated trains.
New York was the most overcrowded city in the Western Hemisphere by the late 19th century. There were parts of New York City that were more overcrowded than Calcutta.
To keep the city moving, engineers had only one place to go: underground. Digging tunnels under any major city was difficult enough, but under Manhattan, they ran into an obstacle that seemed impenetrable. A type of granite called schist.
Manhattan schist is very hard rock that's murder to cut through. It was especially difficult in 1900 because of the relatively primitive construction techniques that people were using. The subway's basically built by hand.
The best way to deal with schist was to avoid it. And the only way to do that was to tunnel over it. But digging tunnels 30 feet in diameter through Manhattan's basements presented enormous challenges. Tunnel diggers encountered a jumble of pilings, sewers, cables, water pipes, and steam mains, all of which were also helping to hold the buildings up. Work began in March 1900. The dangerous job claimed the lives of scores of workers. Ultimately, 7,000 people labored to carve out 22 miles of tunnels. And on October 27, 1904, New York's first subway left City Hall Station for Grand Central. The subway quickly became New York's arteries and veins. By 1929, New York City had built 619 miles of subway, carrying more than 5 million riders a day. By the end of World War II, 8 million people a day were riding over 760 miles of track. But over the next 2 decades, commuters began to buy cars, and city officials stopped investing in the subway. The subway's fateful decline began. Things hit rock bottom during the 1970s and 80s, when subway riders faced delays, graffiti, crime, and the breakdown of up to 108 cars a day.
Those of us that were here in the 80s will never forget that the system was near collapse at one time and literally almost was shutting down.
As New York's finances began to improve, long-delayed repairs could finally be made. More police made the ride safer. Even so, other cities now far surpassed it. Now, cities like San Francisco established a new benchmark for the modern mass transit system, using a new generation of technology. By the 1960s, the Bay Area's roads and bridges were choked with commuters. It seemed like anyone who had left his heart in San Francisco was coming back to pick it up. To break the chokehold, engineers broke ground on the city's first subway, the Bay Area Rapid Transit, called BART. Every step of the way, BART engineers were poised to build a new generation of mass transit.
With a brand new system, we had that opportunity now to start with that blank sheet of paper and say, well, how can we use those technological advances and bring it into something like a transit system?
The answers were quickly apparent. Computers, for one. The trains would become, in effect, driverless, reducing human error and presumably accidents. BART engineers would overcome an obstacle that had plagued New York from the beginning. Water. Both San Francisco and New York are ports. And like New York, San Francisco needed its subway to bring in commuters from far-flung outlying areas. But San Francisco had a problem. The Bay. A major impediment to subway builders. BART engineers proposed constructing a subway tunnel under the bay. But the bay floor is mud, so unstable it would be impossible to bore a tunnel through it. Knowing that they couldn't bore under the bay floor, BART engineers knew they would have to build something that could sit on top of it. It's called an immersed tunnel. Making it in one long piece was not feasible, so they broke the tunnel into 57 segments, each 48 feet in diameter and longer than a football field. As a small army of welders began to stitch each segment's steel skin, a small navy of dredges began to dig a trench 60 feet wide and 100 feet deep into the bay floor to cradle and support the tunnel. The ends of each segment were capped so engineers could float it into position. But the wicked cross currents in the bay made the work of placing these pieces especially difficult. Now, construction divers went to work, helping to maneuver each massive segment within a remarkable 1 inch of its proper place. The 9-ton steel caps were cut away, and San Francisco had a 3.6-mile-long steel tube lying on the bottom of the bay. To provide stability, engineers covered the tube with a 5-foot layer of gravel. Designers had to worry about an enormous potential threat to their tunnel: earthquakes. Just 2 years before the tunnel was built, a significant earthquake had rocked the city. If a really big quake struck, it could conceivably rip the tunnel to pieces and kill hundreds of commuters in a second. Engineers came up with an ingenious solution: steel and Teflon joints at each end of the tunnel. Shock absorbers. That way the tunnel could flex in an earthquake instead of cracking like a stick. The concept worked. In 1989, much of San Francisco was devastated by the monster Loma Prieta quake, measuring a catastrophic 7.1 on the Richter scale. But the subways ran through the Bay Tunnel without incident. Although New York would never have to worry about earthquakes, it had its own unique problem to overcome. It needed a new subway line that would run under the East River to transport commuters from the fastest growing borough in New York City, Queens. Compared to the 4-mile wide San Francisco Bay, the 2 branches of the East River are a short ride, just a total of 550 yards. But this creates enormous problems for builders. River currents that race like rapids through the confined area. Water rushing down the East River to the ocean accelerates to 6 knots, almost twice as fast as the San Francisco Bay. During construction, these killer currents dislodge barges and dredges, and getting each section into place was a nightmare. Longer than a city block and twice as tall as San Francisco's underwater tunnel, each monster section weighed 16,000 tons, the weight of 160 fully loaded 747s. Just getting them to New York was a challenge. It took tugboats 4 days to haul each 375-foot-long segment from the shipyard in Maryland where it was built. Engineers were able to maneuver them within inches of their proper location at the bottom of the East River. But the East River Tunnel project was just a first step. Today, New York's engineers are in the midst of a massive overhaul of the entire system. Hundreds of miles of track will need to be relaid, all stations renovated, and every maintenance facility upgraded. This new super system will include 2,000 new smart cars, a new mega terminal deep under Manhattan, and a fully automated navigation and location system, calling on the very latest technologies and a virtual army of construction and transit workers.
The subway system is basically being reborn, and it's being reborn to the dedicated effort of about 50,000 employees that work those 24 hours, 7 days a week, 365 days, keeping the system running at all times.
And now, as part of the subway's new master plan, even the maintenance systems have become state-of-the-art. Keeping tracks and cars well maintained not only keeps the city moving, it also safeguards the lives of millions of commuters every day. This is the newest weapon in the subway's maintenance arsenal: the geometry train. It's really a laboratory on wheels. The technicians analyze data sent to the computers by 5 powerful lasers mounted on the front and undercarriage of the train, scanning every inch of the rails to make sure they are no more than 1.5 inches out of proper alignment. There's a lot of rail to look at, 1,320 miles of it, enough to stretch from New York City to Miami, Florida. The rails are made of super strong carbon steel, cut into sections 39 feet long, 5.5 inches high, and 2.5 inches wide. "100 times a day, they're pounded by 400-ton trains. And then there's the weather. 100-degree temperature swings between summer and winter, 40 inches of rain, and 29 inches of snow. All these stresses can bend, twist, and shift the rails. And that can cause a derailment. Hundreds of passengers can go flying off the track at 45 miles an hour. So the geometry train stays in the hunt around the clock, 7 days a week. The moment it finds a problem, a repair crew is summoned to the site. The geometry train is also constantly on the lookout for an even more ominous danger: fire. Every tunnel engineer's worst nightmare. It's the smoke not the flames that often does the most damage. At the height of rush hour on Friday, December 28, 1990, a cable sparked and burst into flames, trapping a number 3 train with 900 people on board. 2 died and 180 were injured, mostly from smoke inhalation. Most fires start somewhere along the heavy cable that feeds 600 volts of electricity to the third rail. The third rail is an 800-mile-long electrified steel snake, about 2 feet away from the tracks, providing the power that propels subway cars. If an electrical short occurs in one of the cables, it can ignite a tissue or burger wrapper, and a fire starts to smolder. Even fire prevention has gone high-tech. The geometry train uses infrared technology to record thermal pictures of the entire web of New York subway tracks. White spots show places where the temperature is at least 10 degrees hotter than normal. Potential fires that have to be checked out. Track maintenance and fire prevention are both critical to subway safety. And so is the care and upkeep of New York's 6,000 subway cars. That never-ending task is performed here at the Coney Island Overhaul Shop, the largest subway car repair facility in North America. 750 mechanics providing state-of-the-art health care to as many as 24 of these behemoths at a time. This is definitely not your neighborhood garage.
If you want to compare it to an automobile, a subway car, we hope to last 40 to 50 years. Your own private automobile, if it lasts maybe 10 years, it's a lot.
It takes a full 2 weeks to overhaul a single car. To change all 8 wheels, each weighing 800 pounds, and repair the 4 motors and 8 sets of brakes. Over a car's 40-year lifespan, it will get 24 new motors, 24 new axles, and 48 wheels.
We give a lifetime guarantee here. If the part fails, bring it back and we'll change it.
But even the best maintained cars can't go on forever. Some cars end up beyond repair. Then it's time for their final ride to the end of the line. "35 miles off the coast of South Carolina. They no longer carry passengers, but they continue to perform a valuable service as man-made reefs, providing homes for a huge variety of marine life. But even as the old cars rust in their watery grave, a new generation is rising in New York. These are smart cars. Lighter, stronger, faster, safer, and more durable. Inside and out, every part borrows the very latest advances from science and the military. Their wheels are 100 pounds lighter, but stronger, and they run longer. They'll burn less energy, propelling passengers at 55 miles an hour. But the biggest difference lies under the hood. 136 computers make this by far the smartest subway car ever. Each car's computers control all communications, climate, lighting, doors, and acceleration. It can even reclaim brake heat and convert it to power. These cars must prove they're not only smart, but also tough enough to survive life in the New York subway. To find out, engineers put them through some New York-style low-tech torture. Opening and slamming doors 500 times to see if they jam. Spinning the wheels full speed in both directions for 20 minutes to see if the bearings overheat. Hitting them with downpours to see if they leak. On average, 8 out of 100 cars fail the test, are repaired, and tested again. Not just because they cost $2 million apiece, but because New York's future is riding on them. Smart cars form only one part of a new computerized navigation system that will control where trains are. The new cars and new tracking system are designed to tackle the single most important challenge facing subways all over the world. Finding the most cost-efficient way to carry more riders. Currently, controllers don't have any way to know exactly where each train is.
TSS McInerney, coming to control.
So the official policy is to keep them far apart to minimize the chance of collision.
That's a negative, that's a negative. Head down to the South Ferry, please.
A New York subway train is supposed to run at least 2 city blocks behind the next train to create a safety buffer zone. During rush hour, the distance between trains grows to 10 blocks. Any closer, and the results can be catastrophic. On June 5th, 1995, a Manhattan-bound J train ran a red light and slammed into the rear of an M train stopped on the Williamsburg Bridge, killing the motorman and injuring 50 passengers. And yet, the safety buffer zone is now so big, it creates a lot of empty track, which results in wasted space, time, and money. That's where the new location and navigation system comes in. Using a computer-controlled network of radio antennas and transponders fixed along the track, and lasers mounted under the trains, it will tell controllers exactly where each train is to the foot.
Don't put everything off the express.
Okay, 1013 Delta Stillwell, come into control with an update.
In this way, controllers could shrink the safe distance between trains, allowing 1,000 more cars to run on existing track. The estimated savings will be around $132 billion. But before engineers trust the lives of millions of commuters to invisible laser beams and microchips, they need to be sure the new system will work under any conditions, especially in a snowstorm. To find out, engineers are comparing readings over both dry and snow-covered track. Of course, it's the middle of August, so a Hollywood special effects team is helping create a perfect storm. The findings are encouraging. Even through snow, the laser gives accurate feedback. New York's first laser-guided subways will start carrying riders in the coming years. And the sooner the better. Commuters still endure the longest average daily commute of any large city in the U.S., an agonizing 40 minutes. And by all reports, in a few decades, the number of commuters will grow, along with their commute time. That's why New York is already planning for the future. Well into the 21st century and beyond. Engineers plan to dig a massive new tunnel from Long Island to Manhattan, ending in a spectacular new megaterminal, a dizzying 140 feet below Grand Central Station. Engineers Howard Sackle and Jerry Foreman are leading the design team for the new megaterminal.
I like to call it our aircraft carrier underground because it's about as long as an aircraft carrier. It's about 1,200 feet.
The mega-terminal will be able to handle an army of 80,000 commuters a day and cut down the average round-trip commute by 40 minutes, saving 50,000 hours a day in lost productivity. Constructing the tunnel will be a daunting undertaking. They'll have to dig through some of the toughest granite in the world, under some of the richest real estate on the planet. $6,200 miles of sewers, enough to reach to San Francisco and back. 32 million miles of utility lines, plus the existing maze of subway tunnels and the 3-story deep basements of thousands of skyscrapers. So engineers will have to go down deep. 140 feet deep. That means tackling the bedrock head on. Bedrock, of course, is what put off engineers a century ago. But back in 1900, they didn't have this. An enormous tunnel boring machine that's already digging a tunnel under Manhattan, 800 feet down. New York's Water Tunnel Number 3 has been in the works since 1970. By 2020, the 24-foot wide, 60-mile-long tube will carry 1,300,000,000 gallons of water into New York City every day. A machine like this one dug the breakthrough channel, connecting England and France under the English Channel. They're so massive, they had to be brought underground in pieces, then put together. 30 steel cutting blades spin on a head, ripping through 40 feet of granite a day. By the time they're done, the builders of the mega terminal will have carted out 1.7 million tons of busted granite, enough to fill Shea Stadium 200 feet high. Once the digging is complete, engineers will have a cavern under Manhattan as large as the Chrysler Building laid on its side. It will consume enough energy to light up 15,000 homes a day. But even as New York's engineers were contemplating their ambitious master plan, they were blindsided by an act of war that threatened to cripple not just the subway, but the entire city. The date was September 11th, 2001. At the subway station below the World Trade Center, thousands of commuters were spilling out of packed trains. When the first plane struck at 8:46 a.m., it was felt by commuters 50 feet underground. Engineers decided to take no chances. Any train that could was ordered to bypass the World Trade Center station. Those too close to avoid it began sweeping through and picking up hundreds of stranded commuters. At 9:03, the second plane struck. At 10:05, the first tower collapsed. By then, the station and lines within 20 square blocks of the World Trade Center had been completely evacuated. As a result of these decisive actions, no one in the subway was hurt that terrible day.
To be able to say nobody was killed, nobody was injured, either from our customers or passengers on that day, truly is something that is amazing, and it's one we're very proud of.
When engineers began to piece together a full picture of the damage, their hearts sank.
All I can describe it as, it looked like a mine collapse. It was very eerie to think that this had been a functioning subway system.
What we found is literally beams from the 80th and 70th floors of the World Trade Center when the buildings flat penetrated our station. It penetrated communication rooms, so our communication system was knocked out, our power system was knocked out, our signal system was destroyed. And when you walked into many of the tunnels, what you really found was this wall of debris.
Broken water mains flooded the track with up to 5 feet of water. 8,000 feet of track were unusable. Two busy subway lines that serviced New York's economic heart, Wall Street.
Wall Street is the engine that runs this country, if not the world. We needed to make sure that that engine could survive, could thrive, and continue to operate.
Subway engineers immediately began the cleanup they estimated would take 2 years. But a new unforeseen danger loomed. the Hudson River might flood the subways. It had been held back from the subway tunnels by the World Trade Center's 60-foot deep basement walls. But the basement floors were gone.
When the trade towers went down, they took the basement floors down with them. So the walls had no bracing anymore, which means that they could, collapse inward.
Only a pile of debris was holding back the Hudson River, and a devastating flood that could cripple New York subway. All they could do was plug up the subway tunnel by capping it off at each end and hope it would hold. As rescue workers combed through the rubble of Ground Zero hunting for survivors, subway workers began the arduous and dangerous work of cleaning up. First, they had to pump out millions of gallons of water. That alone took 3 months. When the water was out, they began to shore up the tunnels so that the heavy construction equipment wouldn't come crashing through. For months, 600 workers toiled around the clock. They replaced 5 miles of track and rebuilt 1,400 feet of tunnels. Other workers rebuilt the retaining wall, eliminating the danger of floods. Total cost, $162 million. By September 15, 2002, the subway lines that run through the World Trade Center site were back in business. And the 1.3 million commuters who rely on these subway lines were back on track.
Getting the 1 and 9 up and running again, that's had a major impact in New York. Not just the 1.3 million riders who are affected by having that section of line taken out of service, but I think for all New Yorkers, a sense of normalcy, that we could do it so quickly and that New York is getting back to normal.
Fourteen different subway lines converge on 7 stations in just 4 cramped blocks, transporting 700,000 people a day to and from the financial district. To break this bottleneck, engineers are planning a downtown counterpart to the mega terminal uptown. A massive superstation under the streets of the financial district, with a giant concourse that will connect all 14 subways. The Lower Manhattan Transit Center, as it will be called, will spread over 170,000 square feet, almost the size of an aircraft carrier. It will take 7 years to build and cost $750 million. Engineers are confident their plans will meet the needs of commuters 50, 75, even 100 years to come. And they believe that they can handle the worst that might lie ahead. That scenario might look something like this. It's rush hour on a busy Friday morning. A packed train from Long Island comes across a smoldering track fire that quickly spreads to the first car of the passing train. It explodes into flames, and smoke fills the car. conductors move the frightened passengers to the rear of the train. Up ahead in the mega terminal, engineers have halted all other trains, and emergency crews are rushing to the scene. The train enters the terminal. Its first car, an inferno. The doors spring open, and 1,400 people rush from the rear cars. The giant ventilation fans kick into high gear, sucking the thick, noxious smoke to the surface. An army of firefighters descends on the platform, blasting the fire with high-pressure hoses. And 10 minutes later, it's out. The only injuries are minor. Minutes after that, the trains are running again. Engineers can't guarantee happy endings for every emergency, but they have tried to anticipate all possible disasters. It's been a bumpy ride for New York subways. From the top of the heap to the bottom, and perhaps soon back on top again. With a new super system that will set the standard for decades to come. Once again, New Yorkers will be able to lay claim to having the greatest mass transit system on the planet.